Good morning. Today we're going to discuss Unit 4, Solid State Control of Synchronous Motor Drive. In the earlier classes, in Unit 2, Solid State Control of DC machine we discussed, and Unit 3, Solid State Control of Induction Motor we discussed. So synchronous motor is similar to induction motor control. So both are AC motors. So for controlling the synchronous motor drive, we need power converters. I mean, we have to select the power converters based on the available sources. So the sources may be AC source or DC source. Suppose the available source is AC source. For controlling the synchronous motor drive, we need to convert AC voltage into AC voltage. So we're going to use a cyclo converter. So with the help of cyclo converter, we're going to convert AC into AC. Then we can control the synchronous motor drive. Suppose the available source is DC source. So we must use the inverter for converting DC into AC. So then we can connect with the synchronous motor drive. We can control the synchronous motor drive. So based on the power converter, cyclo converter and inverter, we're going to control the synchronous motor drive. So coming to the syllabus, so the first one, synchronous motor drive. So what you studied in the electrical machines too. So the introduction about synchronous motor drive, then construction and basic principle that we're going to discuss. Then speed control of synchronous motor drive. It means starting methods of three-phase synchronous motor drive. Then voltage source inverter and current source inverter for synchronous motor drive. When the available source is a DC source, so we have to use this VSA and CSA for controlling the synchronous motor drive. Then cyclo converter for synchronous motor drive. When the available source is a AC source, we have to use the cyclo converter for converting AC into AC. Then it's connected with the synchronous motor drive. Then the last one is just source inverter for synchronous motor drive. So generally the just source inverter used to boost the inverter output voltage. So with the help of shoot through and non-shoot through mode of operation. So the just source inverter booster output voltage is better than conventional DC to DC boost converter. So coming to the introduction about synchronous motor drive. So the construction of stator is similar to induction motor drive. So we are giving separate three-phase supply to the energization of stator. Then coming to rotor, so having the two types of rotor, one is salient pole and one is non-salient pole rotor. The non-salient pole rotor is otherwise called as a cylindrical rotor. So the rotor is excited with the help of separate DC supply. So the rotor may be in terms of two types. It may be permanent magnet or it may be electromagnet. If it is electromagnet, we should provide separate DC excitation to the rotor. Suppose if it is permanent magnet, no need of any external supply. So it leads to reduce the losses associated with the DC supply. Then we can use the non-exciter rotors also for synchronous motor. So when we are using synchronous reluctance motor, it's suitable. Then the rotor gets locked. I mean the magnetically locking concept will take place. Then the rotor, I mean the synchronous motor rotates unlike induction motor. I mean it's operating under synchronous speed condition under various loads. I mean low load condition or it may be high load condition. Then coming to the synchronous motor construction, based upon the rotor types, I mean salient pole type and cylindrical type rotor is there. Based upon the rotor types, we are classifying the synchronous motor generally into two types. One is cylindrical rotor based synchronous motor, then second one is salient pole based synchronous motor. So in terms of stator construction is similar for all the type of synchronous motor. And then in terms of rotor, based upon the cylindrical type synchronous motor, here the rotor is made up of cylindrical shape. So that's why it's called a cylindrical type synchronous motor drive. Then second one, the rotor construction is made up of like salient pole type. So the second one is called salient pole synchronous motor drive. So generally, the synchronous motor is one of the most efficient motor, especially for low speed applications and low speed drives. Then it have more ability to control the power factors also. So these are the some advanced features about synchronous motor drive. When coming to the synchronous motor working principle, so the two main parts, the outer part is called stator. I mean, you are giving separate three-phase supply to the stator to energize the stator. Then the inner part is a rotor. So it's an electromagnet. So we have to energize this one with the help of separate DC field excitation. So by applying three-phase external supply, the stator got energized. Once the stator get energized, the rotating magnetic field is generated. So the RMF, I mean the rotating magnetic field starts to moving. So at the same time, we are giving separate DC excitation to the rotor. So the rotor is an electromagnet. So it's get energized. So the separate RMF is generated in the rotor also. So stator having separate RMF, rotor having separate RMF. So when both are the rotating magnetic field, both speeds are getting equal, then what will happen? The magnetic locking will take place between the stator and rotor poles. Once the magnetic locking takes place, then the synchronous motor is operating under synchronous speed condition. So coming to the next one, the same these diagrams which represents the direction of rotation of rotor. So see here, we are giving separate three-phase supply to the stator. So the stator poles are acting as a magnet. I mean, the energized the rotating magnetic field is generated. So the inner rotor, we are giving the already the rotor is a permanent magnet. So it's acting as a magnet. So there is no need of any external excitation. So it leads to eliminate the losses associated with the DC supply. So due to the rotating magnetic field in the stator and rotating magnetic field in the rotor getting locked, so it's called as magnetic locking. So due to that, synchronous motor is operating under synchronous speed condition. So under various types of loads, either it may be high load condition or low load condition, it's operating under synchronous speed condition. It's unlike induction motor. Induction motor cannot operate under synchronous speed condition. So, but synchronous motor is operating under synchronous speed condition under various types of load. It's coming to the electrical frequency. So the electrical frequency is generated under synchronous speed condition, or we can say when the synchronous motor magnetic locking takes place. So Fe should be equal to electrical frequency. So Nm is the motor speed, P is the number of poles in the synchronous motor stator side with respect to 120. So this is the way of calculating electrical frequency for synchronous motor drive. Then rotor voltage regulation. So voltage regulation depends upon the load, power factor and rated speed of the synchronous motor drive. So the voltage regulation depends upon voltage under no load minus voltage under full load condition with respect to voltage under full load condition into 100%. So this is a way to calculate the voltage regulation for synchronous machine. So the voltage regulation varies, depends upon the different power factor values. So for lacking power factor, the voltage regulation is positive in highly. Then for unity power factor, the voltage regulation is positive but in small value. And for leading power factor, the voltage regulation move to negative condition. Next one, synchronous motor drive. So here the rotor generates a counterclockwise torque to make it rotate in the direction opposite to that of stator poles. So during this condition, the net torque and the rotor in one revolution will becomes zero. So therefore, the motor will not develop any starting torque. So it leads to not a self-starting. So to make the motor under self-starting, we are using two conditions. I mean two methods. One is use a variable frequency supply. I mean by varying the frequency in the stator three-phase supply. Then second one is start the synchronous machine like an induction motor. I mean by adding one more extra winding, we can start the synchronous machine under self-starting. The next one, coming to the types of synchronous motor. Generally, 4 types of synchronous motors are available. So wound field synchronous motor. So under wound field are having the two methods. One is cylindrical rotor and one is salient pole rotor. Then second one is permanent magnet motor. Then third one is hysteresis motor. And fourth one synchronous reluctance motor. So according to our syllabus, we're going to discuss the first two methods. So the first one is wound field synchronous motor. In the wound field synchronous motor, as already we discussed, the stator is common for all the type of synchronous motor in terms of construction wise and in terms of operating wise. But coming to the rotor, having electromagnet here. So we require a separate DC supply to energize this electromagnet. So the DC supply is applied through slip rings and brushes. So it contains cylindrical or salient pole construction. What we discussed earlier, the construction of rotor may be in terms of cylindrical type or salient pole type. So based upon that construction, we are having the two methods under wound field synchronous motor. One is a cylindrical rotor wound field motor, and second one is a salient pole wound field motor. The cylindrical rotor is otherwise called as non-salient pole wound field motor. So generally, the salient pole motors are mostly prepared. So due to the cost, the cost wise, the salient pole motor is very low. So mostly we are using the salient pole motor. But for high power and high speed applications, mostly we are preparing the cylindrical type or non-salient pole type rotor. So it's having higher mechanical strength compared to salient pole rotor.